Hello, so this is the second video to the velocity, displacement, distance, and speed lecture number 3. This is going to be number 4, which is just pretty much working out these sample questions that I came up with. And we're going to go through them pretty quickly because I want to make sure that we have plenty of time to do other things, going to the mall or playing soccer or whatever you do. What is position? So position is the place where you are within an x and y axis. We just kind of think of it like as a pointwise. But if you want to use the word reference frame with it, then you can kind of draw. You can draw a picture, but pretty much you would be in a position within the reference frame, and I'll show you how that is. The best way to pretty much do is to draw it. Imagine we are standing by the street. This is our x. Wow, that's terrible. That's our y-axis, that's our x-axis. This is just a still x and y-axis, and we are within this reference frame. But let's say David, I'm thinking of a teacher that's working with me. Let's say someone is driving within a car, and this reference frame is actually moving. So if we call this y and x, we probably would call this x prime and y prime because they're not the same anymore. And you would pretty much say that we would have a point here. Maybe he's sitting on a train on 3 and 2, and then over here he's sitting on 1 and 1. So you could talk about reference frame and say that I am sitting on the bench by the street in a still reference frame, and then David is sitting on in a seat on a train that's moving at 55 miles per hour or something. Alrighty, so pretty much if you want to use position and reference frame, you could say you could have a I am in a certain position within a certain reference frame. So if you want to go above and beyond, you would use reference frame. What's the difference between displacement and distance? If you are my student, I would like you to draw this picture right here. You put in point A, you put a point B, just like we did in the previous video. You connect it with a line. I don't have a nice tool to do it, so I will trust my ability to draw a straight line, which I guess that's the best I can do. And we will label this displacement. Okay, there we go. And now we're going to use the color blue to label distance. And I'll throw a smile at your way if you're going to write down distance is greater than or equal to displacement, because that would be awesome if you did that. We talked about in the last video, the distance could potentially be also a straight line, just like the displacement, which would make them equal. It's a rare occasion, but it could happen. Nothing is impossible. What's the difference? Oh, we already talked about that. What is the displacement of the following from 1, 2 to 2, 3? Well, I'm very glad you asked. There are two ways of doing this. I just cut it into x and y components in the video, but you can also find the actual displacement without cutting it into x and y components. So let's do a new thing. Yes, I'm pretty positive. And the 2 points is 1, 2, 1, 2, and then 2, 3. Alrighty, so to find the displacement of the x is just, because we're saying we're going from here to here, this is the initial displacement, like, I don't know, what do you want to call this? I'm not going to call it anything. It's just from here to there. So it would be the final minus the initial, 2 minus 1, which would be 1. And I did not attach any units, so you don't need any units. In the y direction, it would be 3 minus 2, which equals 1 as well. So it'd be 1, 1. No, it's not 1, 1. That's not the Distance is a number, it's not a coordinate. So I mean displacement. A car driving in a circle and stopping where it started. Find the displacement of that situation. Stopping was a, so the displacement would be 0, right? Because if a car travels and ends up where it started, if it's in the same point, it's like saying, okay, I started here, I ended here. So what's the distance from here to here? And that's 0. There's no distance in between the points. They're on top of each other. A monkey falling from a 200 feet tree. The monkey didn't die from the impact. It was a super monkey. I was a hilarious person back in my day. I came up with that question all by myself. I am so proud of myself. Anyways, it started off at 200 feet. It ended up at 0 feet because it fell on the floor. So the displacement is 200 feet. Bam. No other information is needed. Now we're trying to find the distance of the following. So let's say we try and find the distance from here and here. And then I kind of have to give specification. If I'm saying that I'm going from here to here, I kind of have to say how. In this case, in a straight line. The thing is, when you start at 1, 2, and you end up at 2, 3, which let's say it's right here, right? You could have gotten there in many ways. You could have gotten there straight. You could have gotten there this way. We talk about, keep in mind, we talk about the distance. We are not talking about the displacement. I cannot do this, can I? And then, I don't know. You just know that you started here, you ended here, and the specifications is we went a straight line. That's pretty important. They have to tell you how you got there, because you're looking for the total distance traveled. And since we're talking about the line, we want to know the distance from here to here. Now, when I talk distance, I generally do not cut down in components. The reason why we do it with displacement is because you may want to find the speed or velocity in the x and y. For distance, you do not do this. You do the Pythagorean theorem. So c squared equals a squared plus b squared, or the distance formula. They're the same thing. So distance formula is like this. It is square root of the difference of these two squared. So 2 minus 1. And it doesn't matter if you go 2 minus 1 or 1 minus 2 because you're going to square it anyways. So it usually becomes positive. Anything squared is positive. And then I think that was a 3. 3 minus 2 squared, and that will give you square root of 2, I believe. So this guy is the square root of 2. That is our answer for the distance going from this point to this point. I will say this again. Distance, you typically do not cut in x and y components, but you typically do that for displacement. Later on you will understand why. A car driving in a circle of radius 3 meters one time and stopping where it started. Now the displacement would be 0, just like we talked about before, but the distance wouldn't, because you actually wasted gas, didn't you? So we went in circles radius 3, so we have a circle radius 3, and then the circumference is pi r squared, which is 9r. So what is the distance? It would be 9 pi, because the distance around the circle is 9 pi. I used that using the circumference of a circle. Alrighty, and now we're talking about the super monkey again. A monkey falling from 200 feet tree and bouncing twice. Each time it bounces, it comes back halfway the distance. So it does bounce twice. So we started at 200. It came up 100. It came down 100. It came up 50. It went down 50. I think that means bouncing twice. And then over here, I guess you just like did not bounce at all, which doesn't make sense. But let's just test. Ooh, bounce. We got here. Bounce, and then bam. Yeah, I'm totally right. So we traveled 200, and we traveled 100. Then we traveled 100. Then we traveled 50. and then we travel 50. Add them together, you get, what is this, 5? Yeah, awesome, I can add. So that's how you get this guy. And did I give units? Yes, I did say feet. Do not forget units. Did I forget units for this one? Yeah, 3 meters, which this has to be meters. The circumference of the circle was meters in the previous one. What's the average velocity of a particle between 2 and 9 seconds when it was at blam, bam, and then at 2 seconds at bam? Oh, wait a second, I'm sorry. It was at this point at 2 seconds, and then this point at 9 seconds. Alright, so I can already tell that delta t is 7. I can already tell that delta t, let's just do that first, so I don't have to explain it. So delta t is 7, because 9 minus 2, and then seconds, equals 7 seconds. And seconds, the symbol for seconds is still s. And then, what was the average velocity of the particle? Now, if we're talking about velocity, we may want to, it's a vector quantity. You can cut it into components, which you probably want to do in the future, because later on you're going to have to calculate certain things, like how long something was in the air and stuff like that. So let's just get the velocity, the average velocity in the x first. So from x we went from 1 meter to 3 meters, so it's 3 minus 1. Factor out the m for meters over 7 seconds, which gives you 2 over 7 meters per second. And then you can plug into a calculator if that makes you happy. Significant figures, don't forget, I only have one significant figure. 0.3 meters per second. Now, the known quantities was only 2 and 9 and 2, and they're each just 1 sig fig. So this has to be 1 sig fig. Don't forget. Do not forget your basics. Alrighty. And then for the y, same thing. We were... I have it all written down here. No, I don't. Let's go back. Y, we ended at 1. We started at 5. So for the average y, we started at 5 and ended at 1. So 1 minus 5. It's like the reverse. It always gets me. I always make a mistake. But I'm lucky that you guys won't make those mistakes, because you guys are young, intelligent. Oh, here's a mathematical trick you can use. I mean, it's probably going to be... someone's going to yell at me. But since this is 2 over 7, and that's 4 over 7, it should just be twice this. Although this was part of the estimation, so if you multiplied this by 2, yeah, it'd end up being 0.6. Anyways, so this is going to be negative 0.6, and then let's move this a little bit this way, meters per second. How about that? Yes. Yes, yes, I like it. Alright, let's continue. Average speed problem on the next slide. What is the average speed of the following graph between 0 and 7 seconds? I like this problem. The one that we did in the previous video, I didn't like because it was like x. I mean, whoa, go back. It was like y versus x and then versus t, which is really difficult. But this is way easier, way easier. Because look at this. Our distance axis, our time axis. So our distance axis started, like, let's say we started at 0, times 0, 0. We went all the way up to 2. For some reason we took a break. And then we went up to 4. And then we took another break. And then I don't know, we died or something. I don't know what happened here. We just stopped, right? I need to stop doing that. So we have traveled a total distance of 4. And we have gone 7 seconds. So the average, and you will not believe how easy this problem really is. It was asking for average speed, right? The average speed, so S average, that's how you indicate average, is distance, which is we have gone 4 seconds, 4 meters, over, and this took us 7 seconds. It is 0.6 meters per second. Nice, I like that. Now I'm just gonna make a few comments before I stop this video. The slope of a graph that is distance versus time is velocity, and which is pretty cool. Later on we can actually figure out that if you took the slope of, you can tell that this individual, let's say I was driving a car, right? As time progresses, I was actually moving upwards, which means I'm driving a positive direction. But then, as time progresses, my distance doesn't go up anymore. So I stopped. I took a break for 2 seconds. So my slope, notice my slope is 0. So when the slope is 0, we don't move. Velocity is 0. And then after 4 seconds, we go up again, which means that we're driving again. We're driving in the positive direction. Had this been a negative slope, we would be driving backwards. Like, let's say I was driving home. So I'm just gonna go ahead and stop at that. I will make a kinematics video where we talk about just graphs. I hope you enjoyed this, and you have a good day.